Lesson 38, simplifying expressions using the greatest common factor. First thing we want to go through today is just prime factorization. Prime factorization is a skill that we've already gone through. You may have gone through in previous math classes. But we want to look at 3 different methods of prime factorization, meaning we only want our answers with prime numbers. And remember, a prime number is just any number who has exactly 2 factors. So method 1 is to list the factors and then the prime numbers. So in the picture here, you have 70 and they want you to break down 70. So they broke down 70 with 7 times 10, 7 being a prime number. And then they broke down 10 with it being 2 times 5, which are both prime numbers. And you write them from smallest to largest, 2 times 5 times 7. And if you did the multiplication, it would equal 70. The second method is to use a factor tree, which that's usually the first method that students learn when they're younger. Prime factorize is the factor tree. And so here you can see them breaking down 24 with factors, and you finally get your answer to be with prime numbers. And so that one you can write it as 2 times 2 times 2 times 3, or you can put it as 2 cubed times 3. And then method 3, use division by primes. So here you're always dividing by a prime number, and your goal is to make it all the way down to 1 underneath here. And then all your prime numbers are every number on the side here. So let's take a look at some examples here. We're going to use each of the 3 methods and just practice with those. So if method 1, prime factorize 120. I'll come over here, we'll do 120 using method 1, which was just list them. So 120, a prime number I can take out of 120 would be 3. And 3 times 40 gives us 120. And then I can break down 40. 40 can be 4 and 10, or let's do 2 and 20. And then we can break down 20. So we got our 3, we got our 2, and then we have our 5 times 4. And then we can break that down even further. 3 times 2 times 5, and then this is 2 times 2. So our answer would be 2 times 2 times 2 times 3 times 5. And we can always check our answer. 2 times 2 times 2 is 8. 8 times 5 is 40. 40 times 3 is 120. So that would be our answer using method 1. Second method, prime factorize 180. So we're using the factor tree. So we have 180. Need to break that down. Let's break this down as we can do 20 and 9, because that would be 180. I can break down 20 as 5 times 4, and 4 can be broken down as 2 times 2. 9 can be broken down as 3 times 3. And if I put all my numbers together, it would be 2 times 2 times 3 times 3 times 5. Or you could put it as 2 squared times 3 squared times 5. And if we want to check our answer, 2 times 2 is 4, 3 times 3 is 9, so you got 36. 36 times 5 would give you your 180. And then our third method, method 3, to prime factorize 924. So 924, division by primes, so we're just doing the division upside down. So we want to only divide by prime numbers. So let's divide this one. We'll divide this by 3. 3 goes into 9 3 times. 3 goes into 2 0 times. The 3 goes into 24 8 times. Then we can divide this by prime numbers again. So we have 308 divided by a prime number. Prime number here we would say to be 2. So 308 divided by 2 would give us 154. And then we could divide 154 by 2 again, and then you get 77. You divide that by 7 and you get 11. Divide that by 11 and you get 1. And our goal is always to end up with 1 there. All of our numbers on the side here will be our prime numbers. So we got 2 times 2 times 3 times 7 times 11. And we can always check our answer. 2 times 2 is 4. 4 times 3 is 12. 12 times 7 is 84. 84 times 11 gives us 924. Those are 3 methods we used to prime factorize those numbers. Here we have some bigger numbers here. So prime factorize 2,730. We're using method 1, so let's do that one. 2,730 using prime numbers. 2730 divided by 5. This should be 546. And we could divide that by 3, and that would give us 182. We can divide that by 2. So this would be 5 times 3 times 2. 182 divided by 2 is 91. And we can see if there's any other numbers that we could divide 91 into, and there is. So we have 5 times 3 times 2. We can divide that by 7. 91 divided by 7 is 13. I cannot break down 13 any further, so my answer would be 2 times 3 times 5 times 7 times 13. Next number we have is prime factorize 100. So this one would be the factor tree. So 100, I can break that down with tens, because 10 times 10 is 100. Break down each of these as 2 times 5. Cannot break down those any further, so this would be 2 squared times 5 squared. And our last one here, prime factorize 51 using division by primes. So we got 51. We can divide 51 and 3, and you get 17. 17 is a prime number, so I can divide that by 17, I get 1. So our answer would be 3 times 17. Besides using those 3 methods, we're going to be looking at the greatest common factor and dividing out the greatest common factor. The definition is just the biggest number that can be taken out of all coefficients, and each variable that is in every expression with the smallest exponent. So we can only take out the variable that has the smallest exponent here. This is just one method that they're using here in the picture. They're just breaking down all the factors using prime factors, and then they're grouping them. So they would say this is one group of 2, so that would be a 2. This is another group of 2. Then you have an X, and then you have a Y. And then they would say, they'd multiply all those together and you get 4xy. And they would say that would be the greatest common factor you can divide out of both of them. So let's take a look at some examples here. We got 6a squared plus b cubed times b cubed plus 8a squared, b squared, c squared. So we need to look at 6 and 8. The biggest factor I can take out of both 6 and 8, the common one, is 2. So I can take a 2 out of both of them. And then I look at my a's. The most a or the least amount of a's I have in both of them is 2. So I can take an a squared out of both of them. The b's, the least amount of b's I can take out, or the most b's I can take out of both is 2. And I cannot take a c, divide a c out because this first term here does not have a c. So the greatest common factor in this one would be 2a squared b squared. Next one, the greatest common factor of 8 and 12. The biggest factor I can take out of those would be 4. And then I look at my variables. C, the greatest amount of c's I can take out is 3. That's my smallest exponent. D's, the most d's I can divide out of both of them is 2. And e's is 1. Because I can't take out more than 1 because this one only has 1 e. And the next one here, the greatest common factor of 9 and 12 is 3. Greatest common factor of a to the 4th and a squared is a squared. And the greatest common factor of b to the 5th and b to the 7th is b to the 5th. So that would be our greatest common factor of that expression. Let's work with a few more here. Greatest common factor of 4 and 6 is 2. The most m's I can take out is 2. The most n's is 4. And the most p's would be 4. So that would be our greatest common factor there. Next one, the greatest common factor of 24 and 32. The biggest number I can factor out of both would be 8. The most m's I can take out is just 1. The most n's is 4. And the most p's, I can't take a p out because this first term does not have a p. And the last one here, greatest common factor of 5 and 10 would be 5. The most p's is 1. The most q's would be 2. And the most r's would be 2. So that would be our greatest common factor. Next example is factoring a polynomial. And a polynomial is just a term. You have more than 2 terms in an expression. So factoring a polynomial is the inverse of the distributive property. So instead of multiplying everything on the outside to everything on the inside of the parentheses, you're going to be dividing out the greatest common factor of each. And so here's your polynomial. They're dividing out the greatest common factor. The greatest common factor was 3y, and they divided it out, and you're left with an expression like this. 3y times y squared plus 3 times y minus 2. So let's take a look at an example here. We want to factor this out, so factor out the greatest common factor. The common factor of 6, 8, and 2 is 2. The most x's I can take out of all 3 is just 1x. So what does that leave me with? 6 divided by 2 is 3. X cubed divided by x is just x squared. And then I have 8 divided by 2 is 4. X squared divided by x is just x. Minus 2x divided by 2x is just 1. And there we have factored out that polynomial. Right now, we're not going to worry about factoring. We could actually factor this even further, break down this trinomial into parentheses, but that's not our purpose today. We'll get to that later this year. Next one, the greatest common factor of 9 and 9 is 9. The greatest common factor of x to the 4th and x to the 6th is x to the 4th. And the most y's is y. 9 divided by 9 is 1. X to the 4th divided by x to the 4th is 1. Y squared divided by y is y. So that's why I just have the one y, because everything else is 1s. Minus 9 divided by 9 is 1. X to the 4th divided by x to the 6th would be, or no, x to the 6th divided by x to the 4th would be x squared. And then y divided by y is just 1. So I'm left with an answer of 9x to the fourth y times parentheses y minus x squared. And the last one, 9, 3, and 1, greatest common factor is 1. The most x's I can take out is just 1x. So that leaves me with 9x to the third plus 3x plus 1. We can always check our answer too by just multiplying everything on inside. So x times x to the third is 9x to the fourth. X times 3x is 3x squared. And x times 1 is just plus x. And this is what we had over here. So that's just a quick way of checking your answer when you're dividing out the greatest common factor. A couple other problems here. We have 8 and 6. The greatest common factor of 8 and 6 is 2. The most x's is x squared. The most y's is y to the third. Divide those out. 8 divided by 2 is 4. X to the fifth divided by x squared is x cubed. Y cubed divided by y cubed is just 1. 6 divided by 2 is 3. I have my x squared ready. Y to the 8th divided by y cubed is y to the 5th. So that would be our answer for that one. Common factor of 8 and 12 would be 4. The most d's is d squared. The most e's is e squared. Divide those out. 8 divided by 4 is 2. We have our d squared. We just need another e. So I'm just dividing those out. Plus 12 divided by 4 is 3. D cubed divided by d squared is d. And then I have my e squared. And the last one here, common factor of 12 and 42. We can take a 4 out of, actually not 4, 6. 6 would be the greatest common factor. The most x's is x cubed. The most y's is y squared. And the most z's is just 1z. 12 divided by 6 is 2. X to the fourth divided by x cubed is x. I have my y squared and I have my z. So minus 42 divided by 6 is 7. I have my x cubed. I need another y and I need another z. So the more you work with these, the quicker it goes, because you can see, you can quickly do the math in your head. Example 4, simplifying algebraic fractions. So here, the fractions can only be simplified if the numerator and the denominator have common factors. Okay, so we want to factor out the numerator and the denominator. I can factor out a 3 in the numerator. 3p divided by 3 is just p. 3p, or 3 divided by 3 is 1. And I can factor out a 3 in the denominator. And what I have left is I can cancel out what's the same in both the numerator and denominator. This has a 3, this has a 3. So my answer is just p plus 1. This is what students in the past have tried doing. Not everybody, but a few have tried doing this. They would just go like this, cross this 3 off, this 3 off, and this 3 off, and now I have just p. Don't do that because you're forgetting that there's a plus 1 at the end. So make sure you're just factoring it out properly. Okay. This next one, I can take a 5 out and I can take an x out in the numerator. 5x divided by 5x is just 1. 25 divided by 5 is 5. X squared divided by x is just x. And in the denominator, I want to see if I can take a 5x out. I can take a 5x out. That leaves me with y. The 5x's cancel out, so I'm left with an answer of 1 minus 5x divided by y. And the next one here, I can divide a 4 out. That leaves me with x plus 2 in the numerator. I can divide a 4 out in the denominator. The 4's cancel out, and I'm left with x plus 2. Next one here, I can take a 6a out. That leaves me with 1 minus 6a. because 36a squared divided by 6a is 6a. I can take the 6a out on the bottom and I'm left with a b. The 6a's cancel out, and I'm left with 1 minus 6a divided by b. And the last one here, 6a or 6x plus 18, I can take a 6 out. That leaves me with x plus 3 divided by, I can factor out a 6th here. 6's cancel out, I'm left with x plus 3. And let's take a look at two application problems. Formula h equals negative 16t squared plus 72t plus 12 can be used to represent the height of an object that is launched into the air from 12 feet off the ground with the initial velocity of 72 feet per second. Rewrite the formula by factoring the right side of the using the greatest common factor and making the t squared term positive. Okay, so we need to factor out this, negative 16t squared plus 72t plus 12. So biggest term I can take out of 16, 72, and 12. The biggest number I can take out is a 4, but they said we have to make the t squared positive. So I got to take a positive, divide a negative 4 out. So if I take a negative 4 out here, a negative 4 out here, and a negative 4 out here, I'm left with an answer of negative 4 on the outside. I got 4t squared plus 72 divided by 4 is 18. 18t. And actually this would be a negative, because a positive divided by a negative is a negative, minus 3. And since I can't take any other number out of 4, 18, and 3, this would be my answer here. And the last one here, we have a similar formula. And it says we need to rewrite the formula by factoring the right side using the greatest common factor and making the t squared positive again. Yeah, negative 16t squared plus 60t plus 4. I need to take out the greatest common factor. Greatest common factor of all of them is 4, but I have to make sure my t squared is positive, so I'm going to take out and divide a negative 4 out. And I'm going to do that for all 3 terms. So that would give us a negative 4 times parentheses positive 4t squared minus 60 divided by 4 gives you 15. So minus 15t minus 1. And that would be our answer. So that's our lesson today on prime factorization and breaking down numbers, whether it's prime factorization or using the greatest common factor.